Hi everyone, this is Dr. V.S. Nishok from AC Department, SNS College of Technology. Here we are going to discuss the topic Basic MOS Transistor Action and CMOS Fabrication PWEL process. So here is the outline starting from introduction to the MOS transistors and level of integration based on Moore's law, and then design abstraction levels, and then two mode transistor action, and then PWEL process with different masking levels, and then its summary. Okay, level of integration. So here the transistor level or IC level is from starting era onwards. It is based on the number of transistors. So it is SSI, small scale integration, that is with 10 to 100 transistors. Example, logic gates like AND gate, OR gate, etc. And then medium scale integration goes with the transistors 100 to 1000. So best examples are counters that we are using in the digital circuits. And large scale integration goes with 1000 to 20,000 transistors. So the microprocessors with 8-bit, so that is the best example. And then very large scale integration starts from 20,000 to 1 lakh or 10 lakh transistors. So that is the best example is 16-bit or 32-bit microprocessors is the best example. So here in everywhere we are using these transistors to design any sort of electronic circuits to obtain a better efficient result. So that is the main concept based on this IC classifications. And then ultra large scale integration, so that is about 10 lakh transistors. So about 10 lakh transistors. So will be using a special purpose computers and virtual reality machines and smart sensors. So these are different levels of integration of IC. And then different abstraction level, so based on system level, based on module level, gate level, circuit level, device level. So there are different levels of abstraction. And then coming to Moore's law, so Moore's law defines the number of transistors in the circuit will be doubled every 1.5 years, that is 18 months to 24 months. So that is based on the Moore's law. So why the name MOS? So metal oxide semiconductor transistors. So why we are mentioning it as a MOS, MOS, metal oxide semiconductor transistor. The structure, so if you are seeing here in this diagram, structure, we are having a layer of metal above the gate terminal, and then if you are seeing the layer of oxide, SiO2, so that is available in the oxide layer, and a layer of semiconductor. So the combination of semiconductor, oxide and metal, that forms the transistor that is represented as a metal oxide semiconductor transistor, MOS transistors. And then coming to the two different modes of transistor action. So there is two possible modes of transistor, MOS transistor actions are enhancement mode and depletion mode. So in the enhancement mode, if you are seeing the gate terminal, the input voltage, if it is a positive voltage, so then NMOS transistor and PMOS transistor starts creating a channel and starts improving the current flow between the drain and source terminal of the transistor. So that is mentioned under the category enhancement mode transistor. So in the depletion mode transistor, the voltage through the gate terminal should be the negative terminal, so and it will reduces the conductivity. Example, water tap. Enhancement mode and depletion mode transistor action. So as discussed earlier, so if you are seeing different gate voltages, so that is NMOS enhancement mode. So the positive, as discussed earlier, positive gate voltage is needed, so that it will uses electrons to form a channel and transistor will be in on condition. So in the PMOS enhancement mode, the gate voltage will be the negative, so based on the holes it forms the channel and transistor will be in on condition. And in the NMOS depletion region, in the depletion region means we will be getting the negative voltage only. So it will reduces the conductivity even though the transistor is in on condition. So and then coming to the point, so while comparing the NMOS transistor, PMOS transistor is with less speed. So that is represented here as mu n equal to 2.5 mu p. So mu n represents the NMOS transistor and mu p represents the PMOS transistor. And here we are seeing different levels. So if you here in the enhancement mode, no current flow when the condition VGS greater than threshold voltage. So that is gate voltage greater than the threshold voltage. So here we can see the channel. And in the non-saturation region, when VGS is greater than the threshold voltage, so here there is a slight difference in the channel when compared to the normal condition. So in the saturation region, so there is a little pinch off. If you see the previous thing, so there is a channel, that is reduced channel when comparing to the normal condition. So but here there is much more reduction in the channel, so it will reduce the current flow between the drain and source. So that is mentioned here as a pinch off here. So that is with the condition VDS greater than VGS minus VT. So and coming to this, that's all about the introduction to the MOS transistors. And then coming to the IC fabrication, CMOS IC fabrication process using P-well process. So starting from oxidation. So if you see the first step, starting from the wafer preparation and step one, and then oxidation, and then steps one by one, photolithography, etching, so and then up to the packing. So there are different several 9 to 10 steps are there to make the normal silicon wafer into the IC. So that is done with the help of the CMOS fabrication. So through which we can design the ICs based on our users' interest. So here here there are several steps discussed here: P-well diffusion and the thin oxide oxidation layer, and then pattern polysilicon layer, chemical vapor, and then likewise here PMOS defines N diffusion, it represents the diffusion and contact cuts, and metal layer pattern. So finally metal will be inserted for drain, gate and source terminals, and finally packaging. So these are the several steps of the P-well fabrication process. It is just an introduction to it. And finally, so this is the final structure of the P-well CMOS transistor. So if you are seeing there is a P-well, and in which N-type materials and P-type materials are diffused in order to make the CMOS transistor. So that's all about the today's topic. So we have discussed about some introduction to the ICs and MOS transistors, and we have seen the steps of the CMOS fabrication using P-well. So here is the short assessment related to it. So mu n equal to 2.5 times of mu p. So that we have discussed in this today's topic. And P-well mask levels, so that is CMOS fabrications levels 1, 3, 5, 7. So and then define pinch off. Pinch off is nothing but a condition that occurs when VDS is greater than or equal to VGS minus V threshold. So at this condition the channel will be reduced, drains, that is pinched off. So which will reduce the current flow between the drain and source. So that is called as a pinch off. So that's all about the topic. Thank you all. We can discuss in the next video.